Hello everybody! In this video I will talk about several problems from your homework on the section with inverse functions. I will focus on problems that students had questions about. In particular, we will talk about determining the domain and range of an inverse function. We will talk about restricting the domain of functions that are not one-to-one, and also computing and graphing inverse functions. So let's go ahead and take a look at this first set of problems. We're asked to determine the domain and range of an inverse function and then restrict it to make it one-to-one. If you look at this first graph, okay, the first thing we're going to go ahead and do is compute or determine the domain and range of this particular function. So what is the domain? The domain for this function would be all values that get mapped to something in y, right? So I'm going to highlight it in green, okay? This is our domain, so we go from -8 to +2, okay? And that's on the horizontal x-axis. What about the range of this function? The range would be these values here. Let me highlight it with a different color. Okay, we go from +2 to +6. Okay, that is the range of this function, and this is absolute value function with some transformations, right? Okay, this function is not one-to-one because if I were to make a horizontal line, I have 2 points where the line crosses the graph of this function, okay? Which means this function as is does not have an inverse. However, if we restrict the domain of this function to 2 different intervals, we can have a function that's one-to-one, and thus we can find the inverse, okay? So what do? Split up your domain into 2 intervals, such that if you just restrict it to one half or the other, you have a graph that passes the horizontal line test, okay? So what is our restricted domain? Restricted domain for this function would be what? We go from -8 to -3. That's one part. Okay, that's the left branch of this upside down V, right? Okay, and then from -3 to +2, that would be the other part of the domain. Okay, and if you restrict your function to just one of them, then you will have a one-to-one function, and thus you can find the inverse. Okay. So that's what you do with this particular problem. Let's go ahead and take a look at a couple more of these, but now we'll go a little bit faster. Okay, I have a parabola that's open and down. Okay, so what is my domain for this function here? I'm going to highlight this domain with green. We go from -4 to +8. -4, +8. Okay, what about range? Range goes from +1 to 5, right? How low and how high does the graph of the function go? Okay, so that's my range. We go from +1 to +5. Okay, is this function one-to-one? No. It does not pass the horizontal line test. Okay, so I'm going to split it into 2 parts, and then my restricted domain now for this particular graph, what is that going to look like? Okay, the left part would be from -4 to +2, and then the other interval would be from 2 to +8. Okay, let's take a look at another example. What's happening here? Okay, what is our domain? the domain of this function, let me highlight this. We go from -3 to +3. Okay. What about range? Range is how high and how low does my graph go? Okay. We go from -2 to +2, so that's all of these y values. Okay, from -2 to +2. Is this function 1 to 1? No, it does not pass the horizontal line test. Okay, which means what? We need to restrict the domain of this function if we would like to find an inverse. So what is our restricted domain? Restricted domain would be from -3 to 0. That's the interval where we have this left branch of v, right? And then we go from 0 to 3. This is where we have right branch of this v-looking graph. And then you can think about, okay, if I just restrict it to one of these, all of these horizontal lines will cross the graph at exactly one point. Okay? So this is how you deal with functions that are not one-to-one, and we will need to use this concept again once we're ready to determine inverse functions of trig. Okay, so that's a little bit down the road. Okay, let's take a look at the next set of problems. Okay, first, I'm asked to find the graph of an inverse function. Okay, I see this sketch right here. It doesn't give me a formula. That doesn't matter. We can still find a graph or a sketch, like a rough sketch of this function, of the inverse of this function. Okay, is this function 1 to 1? Yes, it is. Okay, if I make horizontal lines on the sketch, it's only going, all of these lines are going to cross the graph at exactly one point. Okay, so we know the inverse exists. All right, so what does that mean? Okay, one way to find the sketch is look at these points right here. So this point right here is -4, 3. -4, 3. Now for the inverse function, our x and y coordinates will flip, right? So that means I need to find point 3, -4. 3, -4 is right here. 3, -4 is going to be one of the points on the graph of my inverse function. Okay, this point right here is 6, 6. Thankfully, when we flip these two coordinates, we get exactly the same point, right? Now, and let's say you had something like 6, 7, then your other point would have been 7, 6. Okay, and now you make a sketch right here. Okay, and notice that if I make a graph of the identity function, so this is y is equal to x, right? You will see that these two plots are symmetric about this identity function. This is our y is equal to x. Okay, so if this function is f of x, then this function is f inverse of x. And notice that whatever the domain of our function f was, now it's range of f inverse, and vice versa. Range of f becomes the domain of f inverse. Okay, so that's how you graph functions that are one-to-one and you want to find the inverse. Now, the last part is computational. Okay, so for this part, you're asked to determine which pairs of two given functions are inverses. And they ask you to do it algebraically. And so you have this function given to you and all these different multiple choice options. Now my recommendation is to actually find the inverse function instead of trying to match it to one of the functions that's given to you in the multiple choice. Okay, so pretend that we don't know what all of those choices are. You do not have 4 options to pick. Okay, how do we find the inverse of this given function? Okay, so what's the procedure here? We set up our function like this. We have y is equal to this rational expression negative 6x minus 4 over negative 10x plus 3. What we're going to do, we're going to interchange x and y. Okay, so anywhere I see y, I write x. Anywhere I see x, I'm going to write y. Okay, and now the goal is to solve for y. Meaning you need to have y is equal to some expression of x. Okay, so how do we do this? So let's multiply everything by the denominator of this fraction. So we get x, negative 10y plus 3 is equal to negative 6y minus 4. Okay, we multiply everything through, so we get negative 10xy plus 3x. That's what we get on the left. On the right, nothing changes. Okay, now I'm going to isolate anything that we have with the y on one side and everything else on the other side. Okay, so negative 10xy plus 6y, that's going to be on the left. And on the right, we get negative 4 minus 3x. We factor y times negative 10x plus 6 is equal to negative 4 minus 3x. And now the last step is just divide by this expression, negative 10x plus 6. Okay, so we get negative 4 minus 3x over negative 10x plus 6. Okay, which means what is our inverse? Our inverse function. Okay, the order doesn't really matter, but we typically write negative 3x minus 4, so the term that comes with x goes first. Okay, and then on the bottom we get negative 10x plus 6. All right, this is how you find the inverse of this function that's given to us. Okay, so instead of trying to algebraically match it to 4 different functions, I think it's easier and more productive to find the function itself. Okay, and then pick the correct option. Now, of course, you can choose to use the composition, so compose these two. Okay, so let's say compose, what are we going to call it? So compose y with y inverse. Let's say this is our y inverse. If you do this carefully, what do we get? We should get x. We should get identity, right? Or if you compose it this way, y inverse compose with y. Okay, at the end, we should also get x, the identity function. But again, my recommendation is for you to just solve for the inverse by following these steps. Okay, I hope this video was helpful to you guys. Thank you for watching.